This meeting is recorded. The lecture recording is posted on the website. So if you go to D2L website, course materials, and then Zoom link. So all the lecture recordings except lecture 1 recording are here. So lecture 10 was last class. Today is lecture 11. Okay. Okay, so this is a lecture recording. In terms of the course logistics. So maybe it is just right now, it is 6 o'clock. I want to formally welcome you to week 11 of our lecture. So just a reminder about the important due dates. Okay, so this is the course outline. Today we will finish course content. Next class is just review. Okay. So we finished our midterm 1, midterm 2. We have final exam left. That is next Tuesday, a week from today. It is a 40%. Final exam would cover everything. Week 1 to week 12. The timing is 2 hours and a half. 2 hours and a half. I will post practice final exam as soon as possible. Okay. For the exam, we will be able to go back to questions. No, you cannot go back to the questions. If there is another practice exam for lecture 8 to 12, there will be a practice exam covering week 1 to maybe good idea. So there will be a practice test for after test 2, means lecture 8 to 12. You can still practice test 1, practice test 2. Those questions are still the candidates for the final exam questions. Do we have class this Thursday online? Yes, this Thursday is review. It is also online. If you have any questions, email me, okay? Questions are welcome during the class. Questions are also welcomed through the email. Okay, those are the questions I got from the chat. Any other questions? Okay. All right. So today we actually, based on the course schedule, I actually combined 2 modules into 1 module. So today is June the 6th. Yeah, so today we will finish the course content, simple interest, and compound interest. So next Thursday, it is just review, okay, and address questions. Okay, so any questions? Today is the last lecture for content. Next lecture, Thursday, it is review. Questions? Okay. So as usual, I will go to PowerPoint, I will go to lecture, then I will go to the tutorial. Okay. Please stop me at any time if you have any questions. Okay. So here. This lecture is about time value of money. We'll talk about simple and compound interest. For each situation, we need to introduce the future and the present value for simple interest, future and present value for compound interest. By the end of this lecture, you would be able to compute the interest, using the interest for simple interest, and you are going to compute the principal. Interest rate or time using variations of this formula. This formula actually has 3 formulas. So one is interest I equal to P, represent principal, times interest rate R times T. From here, we can divide other formula. So to calculate principal P, it is equal to I interest divided by interest rate times T. And if you want to calculate interest rate R, it is equal to I interest, capital I represent interest, divided by P represent principal times T. Okay, and if you want to calculate T equal to interest I divided by principal times R. R is interest rate. And this, the future value for simple interest is this one. S is the future value. S represents future value equal to principal times 1 plus RT. R is the interest rate. T is the time. Compute the principal, the present value. So from this formula, you can solve for P. P equal to S over 1 plus RT. And we're also going to give you example on compute equivalent or dated value for specified focal dates. So those are about the simple interest, okay? After simple interest, we introduce compound interest. Some slide I will skip, you can easily read why we need simple interest. Okay, this is our formula, is our focus. This capital I is the amount of interest earned. It is decided by 3 items. One is P, the principal. The other is R, annual rate, usually in years. The third one is T, the interest period in years. Make sure you need to match R and T. If R is annual interest, T must be in years. If R is daily interest, T must be in day. If R is a monthly interest, T must be in months. So you have to match R and T. The time, when calculate the time, sometimes we need to know how many days or how many months between 2 dates. Okay. We can use the Excel date function, or we can count, or we can use a table from the textbook. But first of all, let's do some command converting. For example, if you do the conversion from month to year, you divide it by 12. So this is an example. Interest is 4.5% per annum, means per year, per annum. Time is 5 months. So we need to match interest rate T with time, interest rate R with T. Time is 5 months. We need to change 5 months to year. Why? The interest is given in year. Per PA means per year. Okay. So 5 months is how many years? 5 divided by 12, 0.416 years. Okay. Another example, if interest is 5% per year or per annum, time is 26 weeks, we need to convert the weeks to years. We know 1 year has 52 weeks. So T equal to 0.5 years. Similarly, if you are given interest 5.6% per annum, and you are given 185 days, 1 year has 365 days. So T equal to 185 divided by 365 equal to 0.50 years. Okay, questions on converting between time units. Right. How do you find the days between two dates? Usually we refer to this table. Each month, for example, January usually have 31 days, February 28 days, except sometimes February has 29 days. That happened in leap years. Okay. And what is leap year? If a year divided by 4 is a whole number, that year is leap year. For example, year 2000, when you divide it by 4, you got a whole number. So year 2000 is a leap year. Okay, so if 2000 is leap year, 2004, 2008, etc. are leap years. In leap year, February has 29 days. Okay, and when you calculate the days between two dates, usually count, there's a rule of thumb, count the first day, but not the last day. Okay, so this is one rule. And the other one is, I'll give you an example. Found the dates between March 20, 2015 and October 1st, 2015. Calculate the dates between these two. So one way to do it, you count how many days from March 20, 2015 to December 31st, 2015. So there are 274 days. And then how many days from October 1st, 2015 to December 31st, 2015? There are 79 days. So you do subtraction, you get there are 195 days. And these 195 days include March 20, but not October 1st. Okay. I pause for a moment to see if you have any questions. Okay. So this is a table, found the amount, the serial numbers for each day of the year. Okay. So for example, how do we get this 274 for March 20, 2015? So March 20, March 20, 2015. Let me see. It is November. Day of month. $274, 79. 274 is here, but that is October 1st. 20 and then 79. Try to log this 79. This is serial numbers for each day of the year. 79 is here. So March 20, see, March 20 is here. March 20. And then October 1st. This is October 1st. Okay, so you look up those two numbers. Okay, okay, questions. There is another way you can use financial calculator. For example, Texas Instrument BA2 Plus. This calculator is allowed during the final exam. Okay. Okay, there is an Excel way to find the dates between two dates. So if you try to find how many days between March 20, 2015 and October 1st, 2015, you type in the dates here, and then you just do the subtraction. Okay. So I will do a live demo for this one. So. Oh, it is loading. So you just type in, for example, in A1, you type in March, then 2015, and press Enter key. Next, you type in October, space 1, comma, 2015, and then you calculate the dates between two dates equal, you just click A1 minus A2. Actually A2 minus A1, okay? You'll get a positive number. So equal to October 1st minus March 20. So you got 195. Okay. All right, questions? Okay, now let's do the calculation. Found the amount of simple interest. So compute the amount of interest for, if you have $3,900, the interest is 6.18 per annum for 1 year. Question is, what is the amount of simple interest? That is the question. Okay. So to do that, we simply use the formula. I is the interest equal to PRT. P is 3,900. R is 6.18%. T is 1. Okay, so you plug in those numbers and you use your calculator. For simplicity, I will just use Excel. So equal 3,900 times, times 6.18% times 1. So the interest is $241.02. Questions? Okay, next question. 6,540 at 5.5% per annum for 9 months. So the first number is P, principal. The second number, 5.5%, is R. So we need to find the T. To find the T, you need to match T with R. The unit for R is per annum, okay, per year. So you need to change the 9 to year. So 9 divided by 12, you get the unit is year. This number is T. This number is T, okay? And then you use the formula, same formula, R equal to PRT. So I'll do Excel, I equal to P. P is 6,540, R 5.5%, and times T. T is 9/12. 9/12. So this is the interest. Okay, so I'll just copy. Okay, so this is the interest. Questions? Okay, question 3. P is 2,000, R is 3% for 215 days. So you need to convert these days to year. Use 215 divided by 365. This is T. Okay. And then use Excel. Equal to 2,000 times 3% times 215 divided by 365. So this is the interest. Okay. Just copy this. So this is question 3. Any questions? Okay, last question. 500 at 7.13% between January 2016 and August. Okay. So let's do how many days between January 2016 and August 3rd, 2016. Excel. Type in those 2 dates. The first date is January. Oops. Do it. The first number is, maybe I will do it here in B column. January, January 20, 2016. Okay. Alina, thank you for your question. The question was, will we be able to use Excel on our final exam? I'm thinking I will allow you to use Excel. But when you use lockdown browser, you cannot use Excel when you use lockdown browser. So the question is, we already use lockdown browser for test 1, test 2. The final exam, we will have a lot of questions about simple interest, compound interest. So I am thinking final exam, we don't use lockdown browser, we don't use lockdown browser, but we may use the monitor, because we need to know you are the person who write the exam, not you hire somebody to write the exam for you. Okay, so the answer to your question, Excel is allowed, but we do not use lockdown browser. Okay, so stay tuned for announcement, but I can allow you to use Excel. Okay. Thank you, Reggie, for your comments. Okay, so I just type in one date. Okay. Now typing the second date. How many cheat sheets? 3 cheat sheets allowed for. Thank you, Mayura. You are faster than me. 3 cheat sheets, both sides. Okay. 3. Okay. Okay. All right, so let's continue to do this question. Now, thank you for your question. Continue ask questions, okay? Okay, next I'll type in August, A-U-G-U-S-T, August 3rd, 2016. January looks like J-N-U-L. I need to retype it. Looks, it does not register. J-N-U-L, January 2016. Okay, now you do subtraction, equal B2 minus B1. So how many days? 196 days. Okay, so 196 days. So then you use 196 divided by 365. Okay. So I'll go to Excel. Now you use P times R times T. P equal to 500. R equal to 7.13%. 7.13% times T. T is 196 days divided by 365. Okay, you got $19. So this is for this one. Okay, questions? All right. This is another way to find solutions. Okay, I already gave you the solution here. We talked about there are 3 different formulas for this variation. R equal to PRT. You can divide 3 formulas. What is P? What is R? What is T? Okay, so example. What principal will earn interest of $18.20 at 3.25% in 8 months? Okay. So what principal? So the question asks you, what is P? P equal to I over RT. I is $18.20. Interest R, this one is the same as 0.0325. Change percentage to decimal. 8 months is the same as 8/12 years. Unit is years. So T equal to 8/12 R 0.023. And you get a final answer. Okay. Questions? I have problem with my throat, sore throat. Yeah. Right. Okay, this question. Found annual rate of interest required for $744 to earn $54.25 in 10 months. So this question asks you annual rate of interest R equal to I over P times T. I is the interest, 54. P is principal, 744. Right? 10 months is the same as 10/12 years. And this is T. So this is P. This is I. The question asks you to find R. Questions? Okay. Another question. Determine the number of months required to deposit $1,320 to earn $16.50 interest at 3.75. This question asks you number of months, so asks you for T. And then T equal to I over PR, I $16.50, P $1,320, R 0.0375. Plug in all these numbers and you get 0.3333 years. This 3 is repeating. Okay. So it is actually 1/3 years. But the question asks you how many months? The question asks you how many months? You have to translate 1/3 years into months times 12. You get months. Okay. Questions? Okay. Computing future value. Okay. So the future value is S, capital S, is just the principal plus interest. That is the future value. For example, if you have principal 10,000, interest $1,950, the future value, you just need to add those two numbers. That is the future value. Okay. Compute future value. Future value has another name, maturity value. Okay. So future value equal to principal plus I. I is PRT. So S equal to P plus PRT. Factor out P, you get 1 plus RT. This is the formula for future value. S equal to P, bracket 1 plus RT. Okay. Let's take a look at example. On August, Red Flag invested $28,900 in short-term investment that matures on March. This is one day, this is another day. An investment of this length earns 1.3 per annum. How much will the investment be worth at maturity? So the question asks you, what is S? Maturity value is the future value, okay? So to calculate this, we need to use formula for S. Remember, S equal to P times bracket 1 plus RT. What is P? P is 28,900. And what is R? R is 1.3% or 0.013. That is R. And now what is T? So to calculate T, we need to know how many days between those two dates. Okay, the easy way is use Excel to calculate how many days between those two dates. Okay. So I will try to close this one. Okay. So I will delete all of those I did before. Now I will enter two dates. One is August 3rd, 2016. And the other is March 6th. Oops. March 6th, 2017. Okay, I type in the two dates, and then I do subtraction equal to this number minus this number, A2 minus A1. I got 115 days. Okay, so if I want to show formula for future reference, so this is actually this does not make sense. So I will just maybe copy this one. Okay. So this one I use A2 minus A1. The result is 215. And then you 215 have divided by 365. So now let's plug in the number P. This is P. 1 plus R is 0.013 T. 215 divided by 365. Okay, so you just need to figure out what is this number. Again, Excel. So because there are lots of Excel usage, so final exam, I would allow you to use Excel by not using lockdown browser. Oops. Okay, so now we are going to do calculation about equal 28,900 times bracket 1 plus 0.013 times 215 over 365. See, I got these dates does not make sense. You need to format the cell so that it becomes number. Okay, so to do that, right click your mouse, format the cells, select number, then click OK. You got this number. Okay, so this is a disadvantage when using Excel. Sometimes the format problem. Okay, so this is the number. I'll just copy this number to here. Okay. This is the future value. Any questions? So this is the detail. This is using financial calculator. Okay. You see, we get the same number here. Double check. Yes, we get the same number here. Okay. So next. Let's do this example, a new example. Let me see. Compute the value of investment 8 months before the maturity. 8 months. This is 8 months before maturity date and earns interest 6%, has maturity value 884. So this is the diagram. You have maturity value. Maturity value is S, future value. You have R, you have T. T is actually 8/12. The question asks you, what is the investment? So what is the principal here? That is the question. So P equal to, remember S equal to P times 1 plus RT. Then P equal to S over 1 plus RT. S is 884. R is 6%, 0.6. T is 8 months. You need to match the unit for T with the unit for R. So convert months to year. So you need to do, what is this number? Okay, Excel. So I use this cell here, equal 884 divided by bracket 1 plus 0.06 times 8/12. The result is 850. Questions? Okay, so 850 is here. Okay. Computing equivalent values. Let's pick maybe some, okay. Given a principal of 2,000 today, and an interest rate is 3% per annum. So the question asks you, what is 3 months in future? What is the money 3 months in future? So that question asks you, what is S? S equal to P times 1 plus RT. P is 2,000. R 3%. T 3 months. 3 months divided by 12 to change to year. So this is you get. Okay. Next question, 6 months in future. So instead of 3 months, 6 months. So copy down everything, just change 3 to 6. So 6/12. And you got this number. Okay. And this one, 1 year. 1 year, T equal to 1. This T equal to 1. This is T equal to 6/12. T equal to 3/12. So this one, you just use 2,000, 1 bracket, 1 plus 3%, that's it. And you got this number. And then 25 days in future, so T equal to 225 over 365. Plug in T, so P, 3% times 225 over 365. Okay, so now read the question. Given principal 2,000 today, found the money 3 months prior to today. 3 months prior to today. So 3 months prior to today, this is today. Today you have $2,000. This is 3 months. 3 months prior to today. So the question asks you what is the principal here. This is 2,000 is the future value. Future value equal to 2,000. If you're confused, how do I distinguish present value with the future value? This is the timeline. On the left must be principal. The right must be future value. When you draw a timeline, this point is on the left of this timeline, so it is principal. This point is on the right of this line, it is a future value. Okay, so this question, you are asked for principal. Use formula S over 1 plus RT. S is 2,000. R is 3%. T is 3 over 12. So the result is this number. Okay. Next question, 90 days prior to today, again, asks you for P. T equal to 90 over 365. Okay. So S 2,000, R 3%, T 90 over 365. This is the answer. Any questions? Right. Compute equivalent payments. Okay, this is an application question. You are owed payments of 400 due today. 500 due in 5 months. 5 months. 618 due in 1 year. Okay. You have been approached to accept a single payment 9 months from now. This is 9 months from now. This is now. Which allowed interest at 12% per annum. How much will the single payment be? The question is, what is the money here? If you combine 3 payments, there are 3 payments, 400, 500, 618. Combine these 3 into 1 payment. What would be that 1 payment? That is the question. Okay. Okay, so we need to select a focal date. So we select this 9 months as our focal date. Once you select the focal date, anything on the left of the focal date is the present value. Anything on the right of the focal date is the future value. Okay, so from 400 to focal date, we need to find out. The focal date is on the right-hand side of 400. So we need to find out the future value. What is S for this 400 on the focal date? Okay, so S equal to, this is future value, P times 1 plus RT. So P is 400. R is 12%, T is 9 months, see, 9 months, 9 divided by 12. So this is this money here, 400 money, equivalent of 400 money on focal date. Similarly, how much money for this 500 at focal date? So 500 is on the left-hand side. 500 must be principal. We need to calculate this 500. So S equal to P is 500. 1 plus RT. R is 12%. T is 4 months. 4 months is 4 divided by 12. So this is this money. Okay. Next, we compute what is the equivalent money on focal debt for 618. 618 is on right-hand side, focal debt is on left-hand side. So you are computing P, principal, because left-hand side represents the principal. So you are calculating P for this 618. This 618 is S, future value. So P equal to S over 1 plus RT. S is 618. R is 3% or 12%. T is 3 months. See 3 months here. So 3 over 12. Okay. So you add these 3 numbers together, you get the result. Which 3 number? This result plus this result plus this result. 3 numbers added together, that is the one single payment on focal date. Okay. Questions? Questions? Make sure when you go home, you redo this question to see if you can come up with those expressions. Okay. All right, shall we all take a 10 minutes break? After break, we continue. Today, we may have a longer lecture, okay? Because we combine simple interest and compound interest together. Okay, so break back at 7:02. 10 minutes break. Okay, break. Oops. Break back at 7:02 to continue. All right, welcome back from break. Any questions? I just want to show you there is a suggestion for practice questions for lectures 8 to 12. That is a great suggestion. So I would like to release that practice question right now. Please still use the, remember we have practice for test 1, practice for test 2. Please still practice those questions, because this practice question only contain questions from after test 2. However, the final exam will include everything, week 1 to week 12. Okay. So this is a practice exam. I am going to let you know how many questions from each. There are 3 questions from simple interest, 3 questions from compound interest. Remember, the exam question will come from the same pool. See, I have 180 questions for simple interest, 180 for compound interest. And then for chapter 6, that is the exponential and the logarithm function. My question bank has 229. I just pick 3 randomly as practice. If you're lucky, you may have some questions appeared again on final exam because it is randomized. And then I have 3 questions from chapter 7. Chapter 7 is the geometric sequence. Okay, so total I have 12 questions. I will just release it visible. And then I will allow this practice question to do many times. Available date start from today. Today is June the 6th. Okay, start today, no end. Add availability to calendar. Release condition, no release condition, manage special access, no password. Timing, no time limit. Maybe give you, do you want no time limit? Or you want a time, maybe just give you time to familiar yourself with maybe 12 questions. Maybe give you enough time, okay, 60 minutes, okay. So 60 minutes. This is just practice, okay. Time, where is how many times attempts, okay. 1 attempt allowed, no unlimited time. So manage attempts. How many time unlimited? Unlimited on new attempt, only allow answers. Okay. So unlimited time. Why is 1 allowed? Unlimited. And then why still 1? I said unlimited. No save button. Why I cannot change attempts? 1 attempt allowed. Manage attempts. Maybe can I try 10? I try 10 attempts. I'm not sure why I cannot change the attempt. Attempt, a new attempt. Maybe I need to add that. I will figure this out. Right now, I cannot allow you to do the multiple attempts. Why? Highest attempt, highest attempt, 1 attempt. I allow you 10 attempt. Attempt condition, Oh. Okay, anyway, the questions available. It is just I need to increase number of attempts. Okay. I will try to figure out how to increase the attempt. It is here. And if I select 2, 3, there is no save button. Oh, you know what? I click this one, click this, and then I will click save and close. Then I will open it to see the effect, to see how many attempts. Still 1 attempt. Okay, I will figure this out later. Right now, you have just 1 attempt, okay? Sorry about that. Okay, so practice question is available. Please still use the practice test 1, practice test 2, because this practice question only cover simple interest, compound interest, chapter 6, chapter 7. Okay, questions. All right. Let me see, I think you have pressed OK button. Yeah, you're right, but where is the OK button? Alina, thank you so much. I need to press OK button, but I cannot find OK button. Manage attempt. There is OK. Yeah, you're right, Alina. Thank you so much. So I will make it unlimited, but there is an OK button. I need to find out where is the OK button. Oh yeah, it is hidden here. Thank you, Alina. You are genius. So I click OK button. Okay, now unlimited attempts. Okay. Okay, so now it is available. Okay, thank you so much, Alina. All right. Okay, so before the break, we did this equivalent payments. Initially, you have 3 payments. Now you want to make 1 payment. So what is that single 1 payment? Questions on this one? Okay. All right. So we did. So 400, 500. So just add these 3 numbers together. Okay. Maybe I will copy down here. This number, this result is 436, and then 520. This result is 520. And then the last result is 600. This result is 600. Okay, so you just add these 3 numbers together, you get 1 single payment. Okay, and that 1 single payment, 1556. Okay. 1556. That is 1 single payment. Questions? Okay, so we did that. Loan payment, we just focus on the example. Okay, another example. Again, about equivalent replacement payment. An original payment, 1,500 due today. See, this is today, due today, is replaced by 2 equal payments. So we don't know how much is that payment, we call X. Okay, X. Due 2 months from now and 7 months from now. We don't know the amount, but we use X represent the amount. We solve for this X. Interest is 10% per annum. Found X means found X. Okay. So we choose today as the focal date. If this point is focal date, you have 2 months on the right. Today is on left. Okay. So you want to figure out from 2 months when this is X to here. You want to find what is the equivalent value for this X amount. So you want to find here on the focal date, it is on left-hand side. Left-hand side, it is present value. Okay, S1. So present value S1 is X T. Okay, X over 1 plus RT. R is 10%, T is 2 months. Okay. So remember S equal to P, 1 plus RT. P equal to S over 1 plus RT. Those basic formula. Okay. So we want to find the present value because it is on the left. There are 2 points. This one is on the left. We want to find out. Okay. So it is present value. Okay. And similarly, we found 7 months here. This amount translate to here. We want to find what is here. So again, use P equal to S over 1 plus RT. Okay, this S is X. Okay. Then 1 plus RT is 7 months. So these 2 numbers are together should be 1500. So 1X over 1 plus 0.1, 2 over 12 plus 1X over 1 plus 0.1, 7 over 12. This one equal to 1500. So now we have 1 equation, 1 unknown. Technically, we can solve for X. Okay, so now how do we solve for this X? Problem with my throat. Okay, to solve for X, there are many ways to do it. One way you do this. You take away X is the common factor. So you have 1 over 1 plus 0.1, 2 over 12 plus 1 over 1 plus 0.1 times 7 over 12 equal to this one. Then you figure out what is this number, what is this number. Excel, okay? Excel to figure out. You need to do 1 over bracket 1 plus 0.1 times 2 over 12. So this number is this. I will copy later on. Next, you need to figure out 1 over bracket 1 plus 0.1 times 7 over 12. It is this number, okay? And add these 2 numbers together equal to, oops. So equal this number plus this number. So you got this number. So I will copy this as reference. Okay, maybe over here. Okay, so you get X times 1.928488, this number here, equal to 1500. So x equal to 1500 divided by 1.928488. Okay, and then Excel again equal 1500 divided by this number. So you got $777.81. Okay, questions? Good. So now I will maximum the screen. So we did this question. That concludes the simple interest part. Okay, the simple interest part. There are some formula. Interest I equal to PRT. Future value S equal to P times 1 plus RT. A present value P equal to S over 1 plus RT. That is for simple interest. Simple interest. Okay. Questions? Did I record this lecture? Yes. Okay, next is compound interest. For compound interest, we are going to calculate interest, future value, present value. We are going to calculate the long-term promissory notes, solve problems involving equivalent values. Introduction, you can read by yourself. I'll directly jump to here. Comparison of principal. You have 10,000 right now, invested for a term of 5 years at 10% per annum. Okay. If it is a simple interest, so in year 1, if it is a simple interest, in year 1, principal you have 10,000, so interest is 0.1, 10%. 10% is the same as 0.1, okay? And you got interest amount is 1,000, okay? Because of R equal to PRT. P is 10,000, R 0.1, T is 1, year 1. Okay, you got this as interest, but the principal is 10,000. So the balance at the end of year 1, it is 11,000. Questions? Okay. Now again, simple interest. What happened for simple interest in year 2? In year 2, because it is a simple interest, rate is still 0.1, principal is still 10,000, interest is still 1,000. At the end of year 2, you plus this number with this interest, you got 12,000. Okay, so etc., etc. So this is a simple interest situation. At the end of year 5, you got 15,000. 15,000. Now let's compare compound interest. Year 1, you got interest 1,000. The end of year 1, you got the balance 11,000. This is the same as a simple interest. But what happened in year 2? In year 2, interest is this one. Principal becomes 11,000. This is for compound interest. Whereas in simple interest, in year 2, principal still 10,000. That is the difference between simple interest and compound interest. When you do compound interest, you also consider it is interest on interest. You consider the interest as the part of the principal here. That is the difference. Okay, so at the end of year 2, you got this balance. When you calculate interest for year 3, you use 12,100 here. See, use this one. When you have simple interest, year 3, you still use 10,000. But here you use interest on interest is part of principal here. So keep on going. At the end of year 5, you got this amount. See the difference between simple interest and the compound interest. More than 1,000 different when you do simple interest and compound interest. Okay. Region, thank you for your observation. For simple interest, it always increases by the same amount. You are right, Region. Great point. Okay, so this is graphical comparison. When you have the simple interest, Region said, always increase by same amount. See, increase by same amount. But when you have compound interest, increase by different amount. You see, every time it becomes bigger and bigger each time. Okay, so periodic rate of interest versus normal rate of interest. Periodic interest is the interest rate per period. This period could be per day, per month, per quarter. Okay, could be per year. So this periodic interest is different from normal annual rate. Give you example, 5% per annum, compounded semi-annually. Okay, so in this example, 5% is in this example, 5% is annual rate. Is annual rate. Periodic rate. Periodic rate is 2.5% because compounded semi-annually. 1 year has 2 semi-annual. Okay, so we call this 2.5 is a periodic rate. So every half year, the rate is 2.5. If the same question, I change to, I will say 5% per annum, compounded quarterly. Compounded quarterly. I ask you found the periodic rate. The answer is 5% divided by 4 because 1 year has 4 quarters. 1 year has 4 quarters. So the result would be 1.25%. So periodic rate 1.25%. Okay, and now I change the same question to 5% compounded. Instead of quarterly, I change to monthly. I ask you to find periodic rate, 5% compounded monthly. So you use 5% divided by 12. That is periodic rate. Okay, so it should be 0.4 something. Okay, roughly. Okay, questions on periodic rate. Most often, interest rate compounded quarterly, compounded monthly, compounded semi-annually. Okay. So I actually did this. The formula for, we use small letter I represent periodic rate, and we use letter J represent nominal rate or per annum, and M M is the number of compounding periods per year. So there is this formula. Okay. If it is compounded semi-annually, M equal to 2. If it is compounded quarterly, M equal to 4. If it is compounded monthly, M equal to 12. So that is the meaning of 12, the M. And if it is compounded daily, M equal to 365. Okay. Questions? Okay. We already did those, so next time we just use the calculation for future value. So when you have compound interest, this is the formula for future value. Future value equal to present value times 1 plus I. See this I? I is the periodic rate of interest raised to power n. N is the number of compounding periods in the term. Okay. So this is the formula. Let's do example. Do example. Do example. Okay, do this example. A loan for 5,000 with interest 7.75%, compounded semi-annually, is repaid after 5 years, 10 months. What is the amount of interest paid? That is the question. What is the amount of interest paid? To calculate the amount of interest paid, the amount of interest paid equal to future value minus the principal, that is the future interest paid. Okay, so our objective to find out what is the future value. Once we found future value minus 5,000, then we get the answer. Okay, and to find future value, we use formula FV equal to PV 1 plus I raised to power n. PV is 5,000. I is a periodic rate. Remember, we practiced some questions. If you have 7.75% compounded semi-annually divided by 2, you get periodic rate. And then raised to power n. So n in 5 years, 10 months, how many semi-annual in 5 years, 10 months? That is n. 5 years, 10 months is how many semi-annual? That is the question. So first, we convert 5 years, 10 months into year. So 5 years plus 10 months, 10 over 12 is year. Then we get 5.83, 3 is repeating, so 5.833333. And we know 1 year has 2 semi-annual. Okay, so 5.83 times 2 is how many period? This is actually our term n. Should be n, there's a typo here. Okay. And now we raise to power 11.6. 6 is repeating, 6, 6, 6, 6, 7. And now we need to use Excel to do this calculation. So equal 5,000 times bracket 1 plus 7.75% divided by 2 raised to power 11.66666667. And this is our answer. Okay. So this is our answer, future value here. Okay. And once we got this value minus 5,000, that is the interest. Any questions? So the interest is $2,791. Any questions? Okay. We don't introduce financial calculator. If you are interested or have individual questions, you are welcome to ask me individually. Okay, so now let's do another example here. This one here. A deposit of 5,000, earn interest 7%, compounded quarterly for 4 years, 5 months. At that time, interest rate changes to 6%, compounded monthly. What is the value of deposit 3 years after the change in the rate of interest? So this question is a typical two-step question. If I can draw a diagram, you have 5,000 right now. This is now. You have 5,000. And this money stayed for 4 years, 5 months. So from here to here, it is 4 years, 5 months. So after 4 years, 5 months, between 4 years, 5 months, the interest is 7%, compounded quarterly. So periodic interest is 7% divided by 4. And then interest has changed to 6%. So from here to here, interest is 6%, compounded monthly. So 6% divided by 12 is the periodic rate from here to here. And how long is from here to here? It is 3 years here. From here to here, it is 3 years. And the question asks you, what is the money here? That is the question. Calculate the money at this point. Okay. So 2 steps. Step 1, calculate what is the money here at the end of 4 years, 5 months. Step 1. Once we get a number here, we do step 2, calculate the money after another 3 years. Okay. And to do step 1, we need to find the future value FV in step 1. Future value equal to present value 1 plus I raised to power n. PV, present value 5,000. I, 7% divided by 4. N is in 4 years, 5 months. How many quarters? That is the question. Because interest is compounded quarterly. What is term N? You need to answer this question. In 4 years, 5 months, how many quarters? We know 4 years, 1 year has 4 quarters. Okay. So 1 year has 4 quarters. 4 years has 16 quarters. So we need to find out 4 years, 5 months, equal to how many quarter? 1 year has 4 quarter. 4 year has 16 quarter, 4 times 4. And then 5 months is how many quarter? So 1 month is actually 1 quarter has 3 months, right? So 1 month is 1/3 quarter, and then multiply by 5. That is how many quarter in 5 months. Okay, so this result 16 plus 5/3. I will keep fraction format to make sure the result is accurate. So 53/3. That is how many quarter. The unit is quarter. So how many 4 year, 5 months is the same as 43/3 quarters. Let me double check. 4 times 4, 5 months is 5 times 1/3 quarter. Yes, I double checked. The answer is correct. Okay, now raised to power 53/3. Okay, so what is this number? Excel. For 5,000 times bracket 1 plus 7% divided by 4 raised to power bracket 53/3. Okay, so I get this number. Copy this here. So this is this number. In step 1, the money here is this one. Now do step 2. When you do step 2, this $6,793 becomes present value. The status change because this 6,793 is on the left-hand side of this step 2. Okay, so in step 2, you are trying to find what is the money here. You are still trying to find the future value. The same formula, future value equal to PV. I will not repeat the formula, I'll directly type in the formula. PV is the number we just get. $6,793.26. This is present value. And then times 1 plus I. I is 6% divided by 12. 6% divided by 12. And then raised to power n, because during this 3 years, interest is compounded monthly. So 3 years has how many months? 1 year has 12 months. 3 years have 36 months. Okay, so raised to power 36. Okay, and then we need to calculate this number using Excel. So equal this number times bracket 1 plus 6% divided by 12 raised to power 36. So this is the number. $8,129. $8,129. Okay, questions. 2-step questions. If you can do this one confident and comfortably, you should be okay with the compound interest problem. I would strongly suggest when you go home, don't look at solution, directly look at these 4 lines, the given numbers. Can you come up with this number, $8,129. If you're stuck, look at the solution. Questions? All right, so we did that. See this number we get here. Okay, so far we used the calculate the future value. So you can remember future value equal to present value, 1 plus I raised to power n. To solve for PV, it is just future value over 1 plus I raised to power n. Okay. Now let's do an example. Found the principal that will amount to 10,000 in 6 years at 4% per annum, compounded quarterly. So found the principal means found the present value. Present value equal to future value, 1 plus I raised to power n. Future value is 10,000 because it said it will amount to. So this number is future value, 10,000. 1 plus I is 4% compounded quarterly. So 4% divided by 4, compounded quarterly. Then raised to power n. 6 years has how many quarters? 1 year has 4 quarters. 6 years has 24 quarters. That is term n. Any questions? So do this calculation, you'll get this number, 7,875. Questions? We skip the financial calculator. Application questions. Long-term promissory notes. We directly jump to the examples, but we need to explain some concept. For non-interest bearing promissory notes, this is the issue date. We have discount date. We have maturity date. So face value is the same as maturity value. So from discount date to maturity date, that is the discount period. Let's do an example. Found the proceeds of a non-interest bearing note for 3,000. Discounted 2 years before maturity. The interest rate is 9% compounded monthly. So found the proceeds. The proceeds usually refer to present value. Found the present value. So present value equal to future value over 1 plus I raised to power n. Sometimes we also write this formula to future value times 1 plus I raised to power negative n. The same thing. Remember, we studied the property of exponent. Okay. So the same formula, but maybe I prefer this formula, original formula. So what is the future value? This 3,000 is the face value. Face value usually, you see this diagram here, face value is the maturity value. In this example, is 3,000. So you 3,000, 1 plus I is 9% compounded monthly. So 9% divided by 12. 9% divided by 12. And then raised to power. Okay, raised to power. It is 2 year, and it is compounded monthly. 1 year has 12 months. 2 year have 24 months. 2 year have 24 months. And do the calculation, you'll get this number. Okay. So in this promissory notes, you just need to remember the face value usually is the future value. Face value is the maturity value, is the future value. The proceeds refer to present value. Questions? Okay, we skip the financial calculator step. Okay. Let's see. One more question. Looks like we have today is a long lecture. Okay, expect for 3 hours. Maybe shall we take a break? After break, we'll do this example, but I will leave this example here in case you want to find some reference. Okay, guys, let's take a second break. Back at 8 o'clock. Okay, we continue. Okay, welcome back. Hope you have had a nice break. Any questions before we continue? So before break, we did the promissory notes. Now let's do another example. Discounting interest-bearing promissory notes. Found the proceeds of 6-year 900 note bearing interest at 10% compounded quarterly, issued June 2013, discounted on December 1st, 2018 to yield 8.5% compounded semi-annually. So I give you a few moments to digest the given numbers. Let's do the analysis here. Okay, put the given number into the diagram. Cannot show those on. So 900 is the proceeds. So the proceeds is here, usually present value. That is on June 2013. And then it is discounted on December 1st, 2018. Because it is a 6-year note, 6-year note. So from June 1st, 2013, you count 6 years, you will get June 1st, 2019. That is the maturity date. So from here to here, from here to here, 6 years. And then from discount date to maturity date is the discount period. And then from December 1st, 2018 to June 1st, 2019, there are 6 months. So from here to here, 6 months. So again, we are going to do 2 steps. Step 1, found maturity value or future value on June 1st. So we are going to do step 1 here. This is our step 1. What is the future value on June 1st, 2019? Okay. So based on future value formula, future value equal to PV times 1 plus I raised to power n. So from here to here, 6 years. Okay, 1 year has 4 quarters, 6 years has 24 quarters. Why do we use quarter? Because it said 10% compounded quarterly. Okay, for during the 6 years, we have 24 quarters. And 10%, so 10% divided by 4, you go to 2.5%. The same as 0.025. That's how you come up with this number. Okay. So we get our result, $1,627. And once we get this number, step 2, compute the value here. Step 2, that is step 2. Okay. So in step 2, we need to calculate present value because compare this point with this point. Step 2 is on left-hand side. Left-hand side is present value, right-hand side future value. So in step 2, we calculate, there is a typo here, sorry, this should be PV, not FV, okay? So PV equal to, so step 2, PV equal to FV over 1 plus I raised to power n. And in step 2, the interest rate here, it is 8.5% compounded semi-annually. 8.5% compounded semi-annually. So this is this period 8.5% compounded semi-annually divided by 2. So it is 4.25. Okay, so it is 4.25%, the same as 0.0425. Okay, so we get step 1, we get this number. Okay. Plug in, then 1 plus I raised to power n. Okay, n equal to 1 because 6 months is 1/2 year. See here, divided by 2, compounded semi-annually, 6 months. So the final answer we get this number, and this number is here. Okay, questions. 2 steps question. This is step 2. Shall we move on? This is calculator step. Last topic for compound interest is the equivalent values. The concept of equivalent values is similar to we did equivalent value for simple interest. Let's do this example. Date payment of 500 due 3 months ago. So if this is today, 3 months ago, you have 500 due. And then you have 1,000 due today. 2,000 due in 15 months. 2,000 due in 15 months. Okay. So those payments are to be combined into one payment due 6 months. So this is combined into one payment. What is this one payment? 6 months from today at 12% compounded monthly. Initially, you have 3 payments. Now you combine 3 payments into one payment. What is that one payment? Okay. So that is the question. Okay, so we need to do 3 calculations. We need to find out what is the 500. What is the 500 at this point? Then we need to find out what is this 1,000 at this point. And then we need to find out what is this 2,000 at this point. We add those 3 numbers. These 3 arrows represent 3 numbers. We add those 3 numbers together That is the answer for one single payment. Okay, so first let's do this 500. So we have 500 on the left-hand side, this question mark on right-hand side. So obviously we are doing future value. FV equal to PV 1 plus I raised to power n. PV is 500. I is 12% compounded monthly. So 12% divided by 12. Then raised to power n. Okay, so from here, 3 months ago, this is today. And then this is 6 months from today. So how many from here to here? So 3 plus 6, 9 months. Okay, 9 months. So it is compounded monthly. So this raised to power 9. From this point to this point, you have 9 months. Okay, so we need to calculate what is this number. Equal 500 times bracket 1 plus 12 divide 12% divided by 12 raised to power 9. So this is $546. Okay, questions? Similarly, we calculate this $1,000 to here. So we still use future value formula. PV is 1,000. This $1,000. 1 plus I, 12% divided by 12, raised to power n. N is 6 months. Okay. So we need to calculate what is that amount. $1,000 times 1 plus 12% divided by 12 raised to power 6. So this is $1,061. Okay. $1,061. So we get this number. Then we'll do 2,000. What is 2,000 is here. 2,000 is on right-hand side. What we want left-hand side. So we are compute present value this time for 2,000. Present value equal to FV over 1 plus I raised to power n. So future value is 2,000. 1 plus I is 12%, divided by 12, raised to power n. N is, this is 15 months from today, this is 6 months. So from here to here, it is 9 months. Okay, so 9 months. So raised to power 9. Okay, so we need to do this number calculation. I need to move my Excel. So equal 2,000 divided by bracket 1 plus 12% divided by 12 raised to power 9. This is the result. Copy and paste here. Okay, so you got 3 numbers, add all the 3 numbers together. That is the equivalent to one single payment. So I have the 3 numbers right here. I just need to do the sum. Add all these 3 numbers together. Did I do add? Yeah, so this number is the final result. Copy and paste. So So this is the final result, $3,437. Any questions? Okay. We did this, we already did this, double check. So $3,437, the same as we did here, see? Okay. Okay, so another example about equivalent payment. Joe is due to make a payment of $2,500 now. Instead, he has negotiated to make 2 equal payments, 1 year and 2 years from now. Determine the size of equal payments if money is worth 7.5% compounded quarterly. Okay. So usually we choose the today as the focal date. So let's draw the diagram. This person initially 1 payment. Now he needs 2 payments, equivalent of this 1 payment. What are those 2 payments? That is the question. So draw diagram. Initially, this person has 25,000. 1 year from now, he needs to pay X amount money. 2 years from now, X amount. Those 2 payments is the equivalent of 25,000. The question is, what is X? Okay, so we choose today as focal date. We need to know this X. What is the value here for X, 1 year X? Then what is the value here for 2 year X? So for 1 year X, present value equal to, excuse me. So we need to PV equal to FV over 1 plus I raised to power N. This formula is the same as FV 1 plus I raised to power negative N. Okay, so FV is X. X is future value. 1 plus I is 7.5% compounded quarterly. So it is 1.875%. Change to decimal, it is this one. Okay. And 1 year has 4 quarters, so raised to power negative 4. And we get present value is this. Similarly, calculate present value for 2 years. Okay. 2 years has 8 quarters. And this plus this equal to 2,500. So 0.928388x plus 0.861946 x equal to 25,000. 1 equation, 1 unknown. Solve for x. Questions? Okay, and the result for X is $1,396. Okay. Questions? Okay, in summary, this session we did both simple interest, compound interest. We did a summary for simple interest. So this summary, it is for compound interest. There are 2 formulas. One is future value, one is present value. How do you distinguish present value, future value? Present value always on the left-hand side of 2 points. Future value always on the right-hand side of 2 points. 2 dates. Okay. Okay, let's conclude the lecture part. Questions? Looks like we do not have enough time to do the tutorial, and some students will have the questions for test 1, test 2, or any questions. So can I suggest we do the tutorial for simple interest, compound interest on Thursday? Would that work for everyone? Because the rest of time, I have some students need to talk to me individually about test 1, test 2, or any question you will have, please stay. Thank you, Regine. Thank you, Zhu, for your response. So next Tuesday or Thursday, this coming Thursday, we will do tutorial for compound interest, simple interest, and then we'll do some questions for final exam. And the question, I will randomly draw some questions from the test bank. Maybe I will do some practice exam questions as review. And please bring any questions on Thursday. Any question, my lab question, test 1, test 2, lecture, tutorial, any questions, bring that question in class. Alternatively, you can email me for any questions. Okay, when you email me, please allow 2 business days. Okay, and the next Tuesday is our final exam, 2.5 hours. How many questions? Roughly 50 questions. Okay, usually that is 50, 55, that amount. Okay, I haven't finalized the final exam question yet. I will make announcement once it is finalized. Okay, that's conclude today's lecture, but the class is not over because I invite some students have questions. Please stay. We can address questions individually, okay? If you do not have questions, feel free to leave class. Thank you so much for your participation, for helping each other, for your understanding. I'll see you next time on Thursday. Thursday is still the same format, online class, okay? Okay, what is the average for test 2? I remember it is 70. Okay, I can double check. Okay. I will double check the class average for test 2. Give me 1 second. Before I do that, I want to stop recording. Stop recording.